Hello everyone. Today we will start the chapter 5, that is periodic classification of elements. In the series of classification of elements, or we can say that periodic table, there are many periodic tables, or there are many such type of examples which we have to discuss here. Then first is, what is the need of classification of element? It helps in studying the element in an organized manner. We can correlate the properties of similar type of elements by classifying elements into it. So let's start with the Duvenier triad. He was the German scientist who makes some triads, 3 elements in a group. He makes a group of 3 elements having similar property with increasing order of atomic masses. For example, if it is lithium, sodium, potassium, he arranged these 3 because these 3 have similar properties. These are alkali metals. So he arranged these elements in a group, and in the increasing order of atomic masses he arranged them. Increasing order of atomic masses means if the atomic mass of lithium is 7, atomic mass of sodium is 23, and this is 49. He arranged these elements in the increasing order of their atomic masses. By increasing them by arranging them into the increasing order of atomic masses, he found that the average mass of first and third one, this is the average mass of first and third one. Average mass of first and third one is the average mass of, it is 46 by 2 and 23 is approximately the mass of the middle one. His another triad is calcium, strontium, barium. If you know the mass of calcium and barium, it is 147. Sorry, it is 137. 137. Then you can calculate the mass of the strontium, approximate mass of the strontium, as 40 plus 137 by 2 is equal to 177 by 2. So mass is approximately 88.7. 88.7. So its mass is 88.7 according to the Duvenier triad, which is correct. Next triad given by the scientist is chlorine, bromine and iodine. Chlorine, bromine and iodine. Chlorine, bromine and iodine. Mass of the chlorine is 35 and mass of the iodine is 127. Then what will be the mass of the bromine? What will be the mass of the bromine? You can calculate 35 plus 127, 35 plus 127 by 2, approximately 80. So mass of the bromine is 80. But there are only 3 triads at that time. Only 30 elements are known and only 3 triads are possible. But he tried very well for their classification and marked a property which is the average of first and third will be the mass of the middle one. So first write the what is Duvenier triad. We can say that the mass of the middle element in a triad is the average mass of first and third element. So there are demerits of the linear triad. So first is demerits, or we will say that disadvantage of the linear triad. First, he organized only few triads among the then known elements. After the discovery of more elements, could not seems to be follow this triad rule. For example, if we consider, as we know that lithium, sodium, potassium is correct. If we consider sodium, potassium and rubidium, then the mass of the sodium is 23 and the mass of the rubidium is 86. Then the average mass of 23 plus 86 by 2 is equal to more than 39. Much more than 39. It is 80 plus 20, 109. 109 by 2. So this 109 by 2 means about 54. So the mass of the potassium is 30. We know that the mass of the potassium is 39. So this is the wrong triad. Another, when we consider calcium, strontium and barium, this triad is correct. But if we consider magnesium, calcium and strontium, if it is 87 and it is 24, the average of 24 and 87, 24 plus 87 by 2 means it is more than 100. So the mass of the calcium we know is 40. So this is another wrong triad. In this way we can say that the triad is not correct. If we consider chlorine, bromine, iodine, the triad is correct. But if we consider chlorine, bromine, chlorine mass 35, bromine mass, if we consider it is 89 by 2. 89 by 2 means about 45, but the mass of the chlorine is 35 or 37. So this triad is not applicable for all elements of known of known elements, all the known elements. So next triad is given by the Newland. Next triad is Newland's octave. Next triad is Newland's octave. In 1866, Alexander Newland arranged the then known elements in order of their increasing atomic masses. Starting from hydrogen, the then known elements are at that time 56 known elements. Elements which are known are 56. So at that time the known element is 56 elements. Among he arranged all 56 elements into 7 parts and said that the property of first one is exactly the property of the 8th one. When elements are arranged in order of increasing atomic masses into 7 horizontal rows then the properties of 7 horizontal rows, then the properties of every 8th element, EI, eighth element, every 8th element is similar. So he arranged all that time known elements, 56 elements, into octaves and said that according to the sa re ga ma pa dha ni sa, according to the 7 notes, the property of first element is similar to the property of eighth element. So he arranged. We start from hydrogen. Helium, neon, argon, krypton means inert gases are not known at that time. So inert gases in fact discovered after the Mendeleev's periodic table. Li, Be, B, C, N, O, F. 1, 2, 3, 4, 5, 6, 7. So this F is arranged here. Al, Si, P, S. Then Cl, and in his periodic table, cobalt and nickel is placed with hydrogen, fluorine, chlorine and bromine. Cobalt and nickel here, and here with sodium, potassium, copper and rubidium is present. Uranium is present. So there are some demerits present in the periodic table like this, and he arranged all the elements in the increasing order of atomic masses, because atomic mass is the basic fundamental properties known at that time. So he arranged Newland's octave is like this, and say that if it is sa, re, ga, ma, pa, da, ni, then sa again is the eighth element. Start from here. Beryllium 1, 2, 3, 4, 5, 6, 7 and 8. So the property of beryllium is same as the property of magnesium, but it is correct up to the calcium. But this Newland's octave correct up to the calcium. There are some demerits present in it. After the calcium, he arranged chromium, thallium, manganese, iron, whose properties are now not similar to the rest elements present in the groups. So let's discuss the limitations or demerits of Newland's octave. Limitations or demerits. Demerits or limitations or disadvantage, whatever it is, of Newland's octave. First is, it is applicable up to calcium. Up to calcium. Second one is, he assumed only 56 elements existed in nature. Means no more than 56 elements can be discovered in future. You can write it. No new elements can be discovered in future. And third one, like cobalt, nickel, you see the whole periodic table in your book and see there are cobalt and nickel placed in a same slot, and it means some elements were placed in same slot like cobalt, nickel, and sodium, lanthanum, etc. in the same slot. And fourth one, sometimes the properties of at some places properties of elements are not similar. The property of cobalt nickel is dissimilar with the properties of the fluorine, chlorine, bromine, iodine, etc. These are the demerits and limitations of the Newland's octave. In the next class, we will discuss about the Mendeleev's periodic table. If you have any doubt, then you may ask in group or in live classes. Thank you.